Hello everybody, welcome again to Career Ride. In today's video on quantitative aptitude, we are going to learn the chapter area. This is again a very important chapter from the point of view of your entrance exams, from the point of view of your placement tests also. You'll notice that in big paper format, you will find at least 3 to 4 questions from this chapter. And if it is a small paper format, you will find approximately 2 to 3 questions being asked from this chapter. And trust me, all these questions can be very scoring questions if you know just very simple things and you know how to solve these questions properly. So in today's video, we are going to learn all these simple things and the ways to solve these questions in a very easy way. After you have finished learning this chapter, make sure that you go to careerride.com to take the practice questions. So let's begin. So you see, before we begin to solve the questions from this chapter, it is very important to know some very basic things so that you can solve the questions very easily by applying them. The first thing to know here is what actually area is. So you see, area is the amount of space occupied by a two-dimensional space. See, I've very specifically written two-dimensional space here, which means we are talking about only length and breadth here, only two dimensions. We are not talking about height here, otherwise we would be talking about volumes. Now these two-dimensional figures, they can be say a rectangle, it could be a square, it could be a triangle, it could be a circle, or it could be any other hexagon, heptagon, octagon, or any other polygon here. Now when we talk about rectangles, a rectangle we all know would have length and breadth. Area of a rectangle we all know is length into breadth. And what is the perimeter of a rectangle? It is equal to 2 into L plus B, right? Now this is something that we all know. So what is interesting here? Now the next thing that I'm going to tell you here is something really interesting. Now look at the rectangle here and let's draw a diagonal here. Now since we have drawn a diagonal here and we know it is a rectangle, it is a right angled figure here. Okay, now let us mark this diagonal D. This D is the longest distance in this rectangle. What is it? D is the longest distance here. Now what is the application of this information? The application of this information will be in the questions, like for example you will have a question that suppose a rectangular piece of land is given to you here, okay, with length L and breadth B. What is the longest size of the pole that you can place here, or what is the longest size of the bamboo that you can place here? If you are unaware of this concept of diagonal being the longest distance, you'll keep wondering what to do. But if you are aware of this, you will simply go and apply your Pythagoras theorem and you will say D square is equal to L square plus B square. So the longest distance or the longest bamboo that can be placed on this floor would be D is equal to square root of L square plus B square. So you see, it is just the application of the knowledge we have about this figure. Okay, let's move on to the next figure now. Okay, now the next figure usually based on which the questions are asked in this chapter is that of a square. So we have got a square here whose sides are A and its diagonal is D. We know that the area of a square is side square and the side here is A, so it is A square. The perimeter of a square is 4A, 4 into the side, and the side here is A. Now the interesting thing to know here is also that the area of a square is also written as half of D square. D here is the diagonal. This is an interesting thing which you should remember. Okay. Now the area. What is the relation between the area and the sides? So area of a square is directly proportional to the side square, the square of the side, while the perimeter is directly proportional only to the length of the side. Now how does it convert into the questions? How are questions asked from this? So they would ask you that if the side of a square becomes say twice or it becomes tripled, what is going to be the effect on the area? Now if you know just this simple concept, you can solve this question within 10 seconds. Otherwise you would just keep computing. Okay, now we know that the area is directly proportional to side square. So in first case, look here at the table. Okay, so in first case it would be A square, but if the side is doubled, what happens? The area becomes 4A square. In third case, When the side is tripled, the side becomes 3a. What is the effect on the area? It becomes 9 times. So how does the area change with the sides? It is, here it is 1, here it becomes 4 times, here it becomes 9 times. So this is how the area changes. How does the perimeter change? The perimeter in case of the first, when the side is just a, it is 4a we have seen. Now what happens when the side becomes doubled? It becomes 4 into 2a. So it becomes 8a. What happens in the third case when the side is tripled? It becomes 4 into 3a. That is 12a. So how does the perimeter change? In first case it is, if it is 1, second case it just becomes double. In third case it just becomes 3 times. So it changes with the side. If side is a, the perimeter is just 1. If side is doubled, the perimeter doubles. If the side is tripled, the perimeter triples. But the area changes as the square. If the side is doubled, area becomes 4 times. If the side is tripled, the area becomes 9 times. This is a very, very important thing to know and keep in mind, because here I have taken a very easy example. Now they may ask you, if the side becomes, what happens if the side becomes 15 times? What is going to be the effect on the area? Here, if you know this concept, you would not keep computing. You would just simply say it would become 15 square. Or if the side becomes 20 times, the area becomes 20 square. So this is how you apply the concepts if you know them. And you can solve the question within 10 seconds in this case. Okay. Now let's see the next concept here. Okay. So the next important thing that you should know here is incircle and circumcircle. So first let's talk about incircle. If you take a square and if you draw a circle inside it in such a way that it touches the sides of the square from all the sides inside, it is called a incircle. Okay. Now as you see here, the side of the square is a here, and you can see that since the circle is touching all the sides, its diameter here, as you can see from the picture itself, is equal to the side of the square, that is the diameter. So in this case, what would be the radius? The radius would be a by 2, and we know that the area of a square is area of a circle is pi r square. So in this case, the value of r is a by 2. So a by 2 whole square. So this is equal to pi a square upon 4. So in a given condition where the side of the square is a and there is an incircle here, the area of the incircle would be pi a square by 4. Now let's come to circumcircle. In case of a circumcircle, what you have to know here is that when you draw a square and you draw a circle outside it in such a way that it touches all the vertices. You see all the vertices, 1, 2, 3, 4, all the vertices of the square are being touched by this circle. So this is a circumcircle. Now how do you find the diameter of this circumcircle? You can see that since the circle is touching the square from all the sides, this diagonal, the diagonal that we have drawn here already, becomes the diameter of the circumcircle. So what is the diameter? The diameter of the circumcircle here is the diagonal here, right? So what is the diagonal of a square? It is equal to root 2a. This we know already, right? So diameter becomes root 2a. What does the radius become? Radius becomes root 2a by 2, that is equal to a by root 2. Now we already know that the area of a circle is pi r square. So the area in this case becomes pi. What is the value of r? The value of r is a upon root 2 here, the whole square. This is equal to pi a square by 2, right? So this is the area of the circumcircle and this is the area of the incircle. These are the two concepts worth knowing because a lot of questions will depend on this. Okay, now the next popular shape in this chapter is circle and semicircle. All of us know that the area of a circle is pi r squared, circumference is 2 pi r. So there's nothing new here. What you need to pay attention to here is this. length of the arc. So first of all, what is an arc in a circle? Now, if you mark any 2 points on a circle, I have marked it A and B here. Okay. And when you join these 2 points, right? So this arc AB is the arc of the circle here. Okay. Similarly, you can mark any other points. For example, you may mark C and D, right? So this will be arc CD. And when you join this arc to the center, it will throw an angle. The length of this, the distance of A from the center would be R, the radius, and the B, it would be again R, the radius, and it would throw a center, at the center, a angle, which we can say would be theta. Okay. Now, how do you compute the length of this arc? For example, the arc AB. Okay. So, we can compute it by 2 pi r theta upon 360. Okay. Theta is in degrees, 360 is also in degrees. So, you can just say 2 pi r theta upon 360 here. This is the length of this arc AB here. Okay. Or otherwise also, for CD also the formula would be same. Now, when you draw this arc and you draw this whole figure like this, the way I have drawn, okay, you see there is a shaded portion here that I am shading right now. Okay. This is the sector. Okay. Now, how do you find the area of this sector? The area of this sector is equal to half into length of the arc into the radius multiplied by the radius. And when you work it out, it comes out to pi r square theta upon 360. So this is an important thing knowing here to solve the questions from this chapter on circles. Okay, now coming to semicircle. Semicircle, as all of us know, is drawn like this. Its area is half of pi r square, that is half of the circle. Circumference of a semicircle is this, only the curved part that you see on the picture. Okay, you do not include the diameter when you are finding the circumference. Okay, so the circumference is pi r, but the perimeter in case of a semicircle is different from that of a circumference. It is this curved region plus this radius, twice of the radius, because it is the diameter. So the perimeter is this. So if you have to fence a semicircle, you have to find the perimeter in that case. Just remember this, because this is a very, very important thing that you may need to apply. Now, the next important shape for this chapter is triangle. So if I take a triangle ABC whose sides are A, B and C respectively, the area of this triangle can be found by half into base into height, right? Or if you don't, if you are not able to apply this formula, you can use this formula, square root over S into S minus A multiplied by S minus B multiplied by S minus C, where S is equal to A plus B plus C, the whole thing by 2. And we know that ABC are the sides of the triangle respectively. These are the lengths of the sides of the triangle. So this is the formula that you can use in that case. Now all of us know that the triangles can be isosceles triangle, equilateral triangle, right angle triangle. So let's talk about the equilateral triangle a little more. The area of equilateral triangle is root 3 by 4 into side square, and all of us as know the equilateral triangle is such a triangle whose all the sides are equal in length. Now we learnt a little while back that there is a concept called as incircle and semicircle. So if you have an equilateral triangle ABC and you draw a circle inside it in such a way that it touches all the sides of the triangle, then what would you call it? Just try to recollect. You would call it an incircle, right? And the radius of this incircle drawn inside a equilateral triangle would be, the radius would be here A upon 2 root 3. Similarly, if I draw an equilateral triangle and I draw a circle outside it touching all the vertices, right? A, B, C, all the 3 vertices are being touched by the circle. Then this would be what? This would be, we have seen, it would be circumcircle because it is drawn outside, right? and its radius would be what? Its radius will be a upon root 3 if it is an equilateral triangle. So this is another important thing which you must remember. It will help you solve a lot of questions in the chapter. Okay, so let's begin with our question number 1. The first part of the question says the length of a rectangle is increased by 40% and the breadth is decreased by 40%. What will be the change in the area, right? So the question has got a second part also, but we'll deal with it later. This question is nothing but a simple application of your concepts of area of a rectangle and percentages also. So let's see. In the original rectangle, let the length be L and let the breadth be B. So what will be the area? The area will become length into breadth, right? This is the original area. Now in change case, first what happens? Here the length is increased by 40%. So it becomes 140 upon 100. This is how you write the percentages, right? So 140% of the original length. And what happens to the breadth? It decreases by 40%. So it becomes 60%. 60%, how do you write? 60 upon 100 of the original breadth. So what is the area in this case? Here the area becomes 140 upon 100 into L multiplied by 60 upon 100 into breadth, right? What is this? This is nothing but 140 upon 100 into 60 upon 100 into LB. LB is what? LB is the original area, right? And when we solve this, what do we get? We get 84 upon 100 of the original area. What is this 84 upon 100? 8400 upon 100 is nothing but 84%. 84% of the original area, right? So the area decreases. We see that in the new case the area decreases, and decreases by how much? The decrease is by 16%, right? 16% of the original area is the reduction. So this is how the area changes. See, this is quite a simple question, nothing difficult here. Right now you are finding it lengthy because we are going step by step. Once you know how to solve this type of a question and with practice, you will start from this step. And once you start from this step, you'll quickly come to this 84%, right? So pretty simple and easy question. Let's see the second part. Okay, so now moving to the second part of the question. By what percent should the breadth be increased to maintain the same area if the decrease in length is 40%? Okay, so let the original length be L, the original breadth be B. So the area is LB, we know this for a rectangle. Now the length has decreased by 40%, so it has become 60% of the original length. Let the new breadth be B, okay, and we want the area to be same, so LB, right? Now 60%, 60 upon 100 of L multiplied by the new breadth should be equal to the original area. Okay, now when we solve this, what do we get? We get capital B, that is the new breadth, is equal to 100 upon 60 of the original breadth. So it is 1.6 times of the original breadth. Now see this. When we say something has become 1.5 times of something, right? So it means there is a rise in 50%, right? So when something increases and becomes 1.6 times, what does it mean? It means there is a rise of 60% here. So the new breadth should be 60% more than the original breadth. So this should be the change, right? So pretty easy question. If you get stuck with percentages anywhere, know that there is a complete dedicated video on the chapter of percentages. You can visit that video and you can learn the concepts of percentages and practice some questions also from there. Okay, let's move on to the next question. Okay, so let's see question number 2 now. Ram was in a hurry to catch the bus. So rather than walking from A to B and then from B to C along a given rectangular path, he decided to take a shortcut and walk through the diagonal. This saved him a distance which was equal to half of the length of longer side. Find the ratio between the longer and the shorter side. Now see, this question may look a little longer to read, but when you go to solve it, It is a very easy question. So there is no need to get scared. Okay. This is just an application of what we already know. This is a rectangular path that we see here in the diagram, A, B, C, D, and the longer side is L, the shorter side is B. And rather than walking from A to B and then from B to C, Ram takes the shorter distance, that is A to C, that is the diagonal. What is the diagonal of a rectangle? That we already know. By Pythagoras theorem, it is square root of L square plus B square. This is a simple application of Pythagoras theorem. Now, what is given in the question? Had he had walked from A to B and B to C, the distance would have been L plus B. But he walks along the diagonal. So, the distance that he takes is L square plus B square square root. Okay. And the difference between them is equal to half of the longer side. The longer side is length, that is L. Now, what happens here? Here you see, when you try to solve it, you get half L plus B is equal to square root of L square plus B square. This is what? This is nothing but L plus 2B is equal to square root of L square plus B square. Now, to solve it, let's try to square from both the sides. Okay, let's try to square it. This is what? This is L square plus 4B square plus 4LB. Just an application of A plus B whole square. We already know it, right? So, we have measured 2 here. Okay. So, this becomes 4L square plus B square, right? So, now this is just L square plus 4B square plus 4LB is equal to 4L square plus 4B square. Cancelling 4B square from both the sides, what do we get? 4LB is equal to 3L square, isn't it? Now, L gets cancelled here. So, what do we get? We get 4B is equal to 3L. What is the relation between the longer side and the shorter side now? L upon B is equal to 4 upon 3. So, L is to B is equal to 4 is to 3. Isn't it simple? This is quite an easy question to solve, right? Let's move on to the next one. Okay, so now let's see question number 3. How many minimum number of square tiles are needed to cover a rectangular floor of dimension 5.25 meter and 5.10 meter? So this is a rectangle that is given to us with the length 5.25 meter and the breadth 5.10 meter. This is what is given to us. Now we are trying to get rid of the decimal point here first of all. Okay, so this becomes 525 centimeters and this becomes 510 centimeters. Now what he has said that we want the minimum number of square tiles to be used. Since it is a square tiles, it means all the sides would be equal, and since we want to use the minimum number of tiles, it means that the size of this square tile has to be the maximum. Just try to understand it with a real life example. Suppose you have got a jar here, right? And you want to put some cookies in it, but you want the minimum number of cookies to go inside this. What will you do? You will try to make the cookies of biggest size that you can, right? So similarly, we are trying to make a square tile that is the biggest size possible. Okay. Now, how do we find the biggest size possible here? We will try to find the GCD of 525 and 510 here. GCD is nothing but also called as HCF or greatest common divisor. We have learned to find it in the chapter on HCF and LCM. So trying to find it here. This is 105. This is 102. Goes by 3. Okay. So this is 35 and this is 34. Doesn't go beyond this. Okay. So the maximum size possible is 5 into 3 is the GCD here. So that is 15 centimeters. The side of the square can be 15 centimeters. Now, how many number of tiles do we need? Minimum number of tiles, that is area of rectangle upon the area of the square tile, right? This is the number we will get. What is it? This is 525 multiplied by 510. These are the two sides that we are given to us, and we know that the area of a square is side square, that is, so this is 15 into 15 here. So this becomes 35 into 34, right? So this is equal to 1190 tiles. You can try to solve this. You can try to multiply these. Your answer will come to be 1190 tiles. I've already checked it. Okay. So let's see question number 4. The perimeter of a rectangular garden of length 100 meters is 340 meters. A flower bed 5 meter wide is built around it. The gardener works for 2 days on this flower bed and charges rupees 8 per square meter. His fixed charges per day are rupees 300. And what will be the total money paid to the gardener at the end of 2 days on completion of the work? So now this is again a very common type of questions that you will find in most of the exams on this chapter. Okay, so now in this question, what's given is there is a garden in here. Okay, so the inside triangle, let's see the inside triangle first. This is the garden that is given to you, and the length here is 100 meters, it is said. And then there is another rectangle that is drawn outside, and this is 5 meters wide. This is the flower bed here. Okay, so this is 5 meters wide here, this is 5 meters wide here, and this is 5 meters wide here, and this is 5 meters wide here. Okay, so now we have to find the cost of working on this flower bed from all the sides. Okay, from all the sides when the gardener works, what is the cost of working on this flower bed? That is what actually is asked in the question. Now what is given? Let's see. It is given that the perimeter, that is 2 into L plus B, is equal to 340 meters. This is given to you. So L plus B from here becomes 170, right? And it is given to you again that the length is 100 meters. So breadth becomes what? 70 meters is the breadth of the inside rectangle here. So this is 70 and this is 70 and this is 100, right? That is what we marked in the picture right now. Okay, now it is given that the outside rectangle is 5 meters wide. Okay, so you see, let's see the picture. Okay, if we demarcate it like this, okay, because this is 5 meters wide, this is 5 meters wide, this is 5 meters here, this is 5 meters here. Let's see the lower end. Okay, this is 5 meters here, this is 5, so this is 5 here and this is 5 here, right? This is how it is. Okay, now what happens? The length of the outside rectangle, how much will it be? 100 plus 5 plus 5, 100 plus 5 plus 5. Let's see the lower length. Okay, so it is given that this is 100 plus, what is the extension? 5 this side, 5 this side. So the length here becomes 110 meters. Why? 100 plus 5 extension on one side and 5 extension on another side. This is 110. Similarly, the breadth becomes 70 plus 5 plus 5, 70 plus 5 plus 5. So this becomes 80. Okay. What is the area? Area of the inside rectangle is what? It is given to you 100 into 70. This is 7000. And the area of the outside rectangle is given to you. Now you can find it out very easily. It is 110 into 80. This is equal to 8800. So what is the total area of the flower bed now? Area of the flower bed is AO minus AI. This is equal to 1800 meters square, right? Now what is the cost of working on this flower bed? It is given that he charges rupees 8 per square meter. So what is the total area of the flower bed now? It is 1800. So 1800 into 8 multiplied by 8. This is equal to 8 8 is 64, 6, 8 1 8, 12, 13, 14. 14,400 rupees. But wait, we are not done yet. because it is also given that the gardener charges rupees 300 per day is the fixed charge of the gardener. Okay, so this was the cost of gardening. 14,400 that we found out was the cost of gardening, but there is a fixed cost, and that is rupees 300 per day. And for how many days he works? He works for 2 days. So it is 300 multiplied by 2, right? So this total comes out to be 15,000 rupees. So at the end of 2 days, for the total work, the amount that is paid to the gardener is rupees 15,000. Okay, right now it will look a little lengthy to you because we have seen right from the base. But once you know this type of questions, once you have practiced this, you will start right from AO minus AI. This is what you will be able to do with practice, right? So let's go to the next question now. Okay, now the question number 5 here is, a rectangular garden 100 meter by 80 meter has two mutually perpendicular footpaths running across it through the center. One footpath runs across the length while the second one runs across the breadth. The width of both the footpath is 10 meters. Find the cost of graveling the footpath at the rate of 35 rupees per square meter. Now this is the next variety of question in this chapter that you will find in most of the exams. Okay, but these questions are again very easy if you know how to solve them. And let's see how to go ahead. So you are given a rectangle here. Let's see the picture. Here the rectangle is, the length is given 10 meter, the breadth is given 80 meters. Now it is said that there are two mutually perpendicular rectangular paths in the center. Okay, so let us see. This is the first path and this is the second path. And what is the width? The width is 10 meters. The width of this other horizontal path is also 10 meters. And what is the length of this horizontal path? It is parallel to the length of the original rectangle. So it will also be 100. And what is the length of this breadth of this other path? The perpendicular one, the vertical one, it is again 80 meters because it is parallel to the breadth of this original rectangle. Okay, so basically the question is asking you to find the area of these two inside rectangles. Okay, the first rectangle and the second rectangle. Okay, now let's see what is the area of the first rectangle. The first rectangle is 10 multiplied by 80, right? This is 800 meters square. The area of the second rectangle is 100 into 10, that is 1000 meters square. So now you would think that the total area here should be 1800 meters square, right? This is what you would think. This is the area to be gravelled, but this is not correct. This is wrong. Why this is wrong? Because you have to consider the center of this rectangle where the paths are drawn. So come to the picture again and you will see that there is a square in the center which is formed because the two paths have intersected here, and I have marked it with red color here. So this we have counted twice. We have counted it while finding the area for the first rectangle and while finding the area for the second rectangle also. So this is something that we need to deduce from the area that we have found out right now. That is 1800 meters square. From there we have to deduce the area of this square. Okay, so what are the dimensions of this square? It is 10 by 10 square because it is 10 meters wide and 10 meters length is also there, right? So what is the area of this square? Area of the square center square is 10 by 10. So this is equal to 100 meters square. So what is the actual area to be gravelled now? It is 1800 that we found out, 1800 meters square minus 100 meters square that we have counted twice. So this is equal to 1700 meters square actually is the area that needs to be gravelled. This is the area of the footpath. And what is the rate of doing this? The rate of doing this is multiplied by 35. So what is the total, what is the answer you get here? You get 59,500 is your answer here. So this is the thing that you need to know here, that you have to deduce the area of the square in the center here. Okay, So once you know this thing, these type of questions become very, very easy. Let's move on to the next question now. Okay, so now come to the next variety of the questions that you'll find in this chapter. Here a figure will be given to you and you'll be asked the area of the shaded portion. Okay, so the question here says that find the area of the shaded portion of the given figure when it is given that r is equal to 7 centimeter. So first of all we have to see what is r here. So let's come to the figure here. R, okay, it is the area, this is the radius of a circle. Okay. Now the biggest trick to solve these type of questions is try to simplify the figure. Okay. We don't know whether the box given here outside is a square, it's a rectangle. It is not given anywhere. So let's first of all find that so that we can apply the right kind of formula. Okay. So let's make this kind of a little drawing here first of all. Okay. See the figure? Okay. Now this is what I'm drawing here and I'm drawing something here also. What is this? This is radius. This is also radius. And if I come to the vertical line that I've just drawn, this is also radius, this is radius, this is radius, and this is radius. So basically I see that if I see the length of this side, it is the sum of 4 radii. This is 4r. And when I come to this side, I see that again it is the sum of 4 radii, 1, 2, 3 and 4. So this is also 4r, which tells me that this figure, this box outside, is actually a square here. Fantastic. Now we know that the area of a square is equal to what? Side square. What is the side here? It is 4r. So 4r square, that is 16r square. Now we are given with the circles, but there are 4 of them. Area of one circle is what? We know that pi r square, right? But there are 4 such circles, so it will be 4 pi r square, right? Because there are 4 circles. Now what is the area of the shaded portion? Area of the shaded portion is area of the square minus area of the circles, area of 4 circles. Okay. So what is it? It is 16r square minus 4 pi r square. Now solving this is very easy. 4r square, 4 minus 22 upon 7. So this is equal to 4 into 7 here. 4 sevens are 28 minus 22 upon 7. Right? So this gives me 4 into 7 into 6. 6 sevens are 42. 42 and this is 168. 168 what? 168 centimeter square. This unit is very, very important here. So what is the biggest trick? The biggest trick here is simplify the figure as much as you can here. Simplify the figure is what you have to do. Okay. Question number 7. An equilateral triangle is drawn on the diagonal of a square of side A. What is the relation between the areas of the triangle and the square? So these type of questions are again very easy questions if you are able to apply your basics correctly. So we are given a square here with side A and we know that the diagonal of a square is root 2a. This we can compute by Pythagoras theorem also, and otherwise also we know that. Now if a equilateral triangle is drawn using this diagonal as the base, it will be something like this, for example, say, okay, and its one side is root 2a, so other sides will also be root 2a, right? So now we know that the area of the square is equal to side square. What is side here? Side here is a square. So area of the square is a square. What is the area of an equilateral triangle? Area of an equilateral triangle is root 3 by 4 into side square. Okay. So what is the length of the side here? In this case it is root 3 by 4. Side is root 2a. Root 2a square. So this is equal to root 3 by 4 multiplied by 2a square. So this is simple now. Okay. So area, what is the relation between the areas? So area of the triangle divided by the area of the square. So this is equal to root 3 by 2 a square divided by a square. This is equal to what? This is equal to root 3 by 2. So the relation here is root 3 is to 2. This is how the area of the triangle and the area of the square have the relationship between them here. Okay, now let's see question number 8. The sides of a triangle are 3 centimeter, 4 centimeter and 5 centimeter. Find the area and the perimeter of the triangle formed by joining the midpoints of the 3 sides of the original triangle. Okay, so what is given to us here? We are given with a triangle here. Okay, A, B and C, let's say. So in this type of a question, the first thing that you should check is whether this is a right angle triangle or not. This question is pretty easy, but it is a little tricky. So you'll have to pay a little attention. Don't jump into the calculations immediately. First of all, try to check if it is a right angled triangle or not. How would you check that? We know that in a right angled triangle, the hypotenuse square is equal to L square plus B square. If it is a right angled triangle, this condition should be satisfied. Are the given figures satisfying this condition? Let's check. Because in this case we can see that 5 square is equal to 3 square plus 4 square. We can write like this. So definitely the condition is getting satisfied because 25 is equal to 9 plus 16. So basically the triangle that is given to us is a right angled triangle. Now things become a little more simple here. Okay, A, B and C. This is a right angled triangle here. Okay, and what the question says? It says that a new triangle is formed by joining the middle points of the sides. So this is something like this. See the drawing that I am making in the right angled triangle here, and these points are E, F, G, let's say. Now there is an important thing that you have to know here. Whenever the midpoints of the sides of a triangle are joined, basically there are 4 triangles formed in this figure, right angle triangle. The first one is this, second, third and fourth. And the interesting thing about these triangles is all of these have the same area. They have the same area. So the original triangle gets divided into 4 triangles with same area. So what is the area of the original triangle? It is equal to half into base into altitude, right? Altitude is what? Height. So in this case, our hypotenuse is 5 centimeter and rest everything is 3 and 4 are either base or height. So let's place them here. So what does it become? It becomes 3 into 4 into half, that is equal to 6 centimeter square. So the area of the original triangle ABC is equal to 6 centimeter square. And now I just told you that when you join the midpoints, the triangle gets divided into 4 triangles with equal sides. So what is the area of the triangle EFG now? It is equal to 6 upon 4 centimeter squares. So this is equal to 3 by 2 centimeter square. So this is about area. Okay. Now we are also being asked about the perimeter here. So now again pay attention. When you join the midpoints of the triangle, right? So what happens here is, now suppose you join, pay attention to this new diagram that I am drawing. Okay. This is the new diagram that I am drawing. A, B, C. When you join the midpoints, this EF, it will be parallel to BC. Okay. And it will be half in dimension. Okay. So if this is 3, this will be 3 by 2. Okay. And this happens with all the sides. Right. So now this is how the new triangle is formed. Okay. So we are given that the original triangle has the sides 3, 4 and 5 centimeter. Sides of original triangle. Right? Now what happens? Each of the sides, the midpoints are joined. So each of the sides become half. So they become 3 by 2, 4 by 2 and 5 by 2 centimeter respectively. So what is the perimeter here? The perimeter becomes 3 plus 4 plus 5 by 2. That is equal to 3 plus 4 is 7. 7 plus 5 is 12 by 2. That is equal to 6 centimeter actually. So this is the perimeter. The perimeter in this case is 6 centimeters and the area in this case is 3 by 2 centimeters square. I hope you are able to follow this question. If not, you can replay the video, this much part, and understand it clearly. Question number 9. If the length of the median of an equilateral triangle is m, find its area. Now, this is also a simple question. You just have to know the concept of median in an equilateral triangle here. Okay, so let us first draw an equilateral triangle here. Okay, let us name it A, B and C, and let us assume that its sides are A and A. Now the median is drawn from this vertex A and it touches the opposite side here at say point D. Now what's interesting about the median of an equilateral triangle is it is same as the altitude of this triangle in case of an equilateral triangle only. Okay, so it means it forms a 90-degree angle here and it also bisects the opposite side, which means BD is equal to A by 2 is equal to DC. Okay, so and the length of this median given is M here. Okay, so now triangle ABD, it is a right angled triangle. Okay, so what does it mean? It means that A square is equal to A by 2 square plus M square. By Pythagoras theorem we know that. Okay, so A square is equal to A square upon 4 plus M square. What is the value of M square we get from here? We get A square minus A square upon 4, that is equal to 3 by 4 of A square. So this is the relationship between M square and A square right now. Okay, now the area of an equilateral triangle ABC is equal to root 3 by 4 A square. This is what we know. Okay, A here is the side, so this becomes root 3 by 4. What is the relationship between M square and A square? A square is equal to 4 M square upon 3. Am I right? We can easily solve this now. This is equal to root 3 M square upon 3, or if you want to further simplify it, it is M square upon root 3. Your answer could be given in this form or in this form in the paper. Pay attention and choose the right option. Question number 10. 4 horses are tied with the help of a 14-meter long rope at the corners of a rectangular field 60 meters by 45 meters. The horses can't reach each other. Find the area the horses leave ungrazed. Okay, so you would notice that this is again a very common type of a question. It is quite a very popular question in all the exams that you see. Looks difficult but a very easy question to solve. Just the application of what you already know. Okay, so what we know here is that the figure given here is a rectangular field with length 60 meters and breadth 45 meters. Okay, now let's come to the corner A. A horse is tied here. Okay, and it is tied with a rope whose length is 14 meters. Sorry. Okay, so now this horse can move in the area like this, right? It will move in a circle with the radius 14 meters, right? It cannot go beyond that. So what the question is basically trying to ask you is, to find the area of this sector, because the garden is here, the field is here, the horse will graze only this much area, right? And similarly there are three other horses tied to three other corners. Okay, so since this is a rectangle, the angle here is 90 degree, we know. Okay, and what is the area of sector? Since it is the first sector that we are dealing with here, the horse 1, how much area the horse 1 grazes? Okay, it is equal to pi r square theta upon 360. This is what we learnt when we were learning the area of sectors, right, in the circle. So here the value of pi is 22 upon 7, we know. R here is 14. So 14 into 14, theta is the angle at A, that is 90 degree here, right? And divided by 360. Now this is pretty easy to solve. 9 4s are 36. 2 7 2 7, right? So basically what we are left with is 22 into 7. This is the area that the first horse grazes, and it is equal to 154 meter square. Now there are 4 such horses. So what is the total area grazed by these horses? It is equal to S1 plus S2 plus S3 plus S4, right? So that would be equal to 4 into 154, right? At each of the corners, see the figure, at each of the corners there is a horse. So the area grazed will be 154 multiplied by 4, that is equal to 616 meter square. Okay, now what is the area of the rectangular field? The area of the rectangular field is length into breadth. So that is equal to 60 multiplied by 45. Okay, so this is equal to 2700 meter square. Okay, so now basically what the question is asking you, to find the area ungrazed. Okay, so what is the total area? The total area here is the area of the rectangle, and what is the grazed area? The grazed area is 616. The 4 horses graze 616 meter square area, right? So what is left ungrazed? So that is equal to 2700 minus 616, right? So this is equal to 2084 meter square. Okay, so this is basically, look at the figure, this is basically this area that we are trying to find out here in the question. So quite a pretty easy question, just an application of what you already know. So I really hope that this video on area will be useful to you in solving the questions from this chapter. If you want to practice more questions on this chapter, you can go to careerright.com. You'll find a lot of practice questions there. If you have found this video useful, do give it a thumbs up, and for more such videos, do subscribe to the channel. I'll see you very soon with a new video. Thank you and bye-bye till then.